Today I'm going to show you how you can save yourself around $400 to $500 from replacing your door opener with this fix right here, and it only costs $1. It's insane, simple and easy to do. So this is a linear model ld050. Okay, so we have 3 wires, bean, common, and push button. I'm not sure what the voltage is supposed to be, but we'll measure it. It says it's not working. It's got 120 plugged in. You just need to change both the switches to make sure that they're not interfering with anything. We have power applied. And we're going to look at it real quick and see what we can figure out. I'm going to measure the voltage here and see if there's anything. There's the circuit board on the back. I don't see anything burnt right off the bat. And then I'll look for, measure the voltages, and I'll look for something later. I'll look for like cold solder joints or anything like that. We'll see. And we do. Alright, so let's switch this over to DC. I'm going to put it on 20 volts. We have nothing on the push button and common. And center we have 12 volts. Okay. Now, here's another garage door opener. I'm going to see if it's the same model and measure to see if that's similar. The push button, I'm reading 5.28 volts. So that's what it should be. Now I removed power, and I'm going to remove these 2 screws here. I'm going to remove these wires. I'm going to have to take and remove this harness here and remove that harness there. And I think the board will just come right off from that point. I don't think that attached to anything except for the board. That's right. Good. Hit the board down. I'm going to remove these 3 screws here. That way I can take and remove these 2 screws and can pull this housing back and inspect any traces. And I'll put this on a piece of craft paper, that way I won't scratch up any tables or anything like that. Just know, I don't think there's anything in here that's worth being concerned about touching. But you could have some potential buildup from static. Just putting that out there right now before anybody else tries to correct anything. Okay, so here's the little antenna wire. And this is where I wanted to get to and look and see solder joints. See where we're at and that sort. And see where the solder joints come and go from. 5-volt systems and that stuff. This is your push button area. And we have a diode and resistor, 2 resistors. And they go into this trace here that feed down below. So I'm just have to look at it and see what I can find out. I don't know if there's a 5-volt regulator anywhere that needs to be looked at. but we'll get to it. I did notice this thing's got a little warm, not too bad. What I'm measuring next is the 12-volt regulator, and we're going to see if it has output. I'm going to go back to this to make sure. Yep, that's got nothing. And then we're going to go to this side of the diode to ground. I got nothing. And should be nothing. Okay. Alright, so the output of the 12-volt regulator is bad. So, let's see. I do have power removed. I'm going to bring it back down off of the unit. It should be just a 12-volt transistor. I could probably get it off Amazon. I'll show you the part number. It will be U3, and he is a 78L12, ST78L12. This guy right here puts out power for your push button. I know I have input, and I know I don't have any output. So, I have to look and make sure there's a circuitry on the output. There's a diode right there, making sure that it doesn't have anything else. Then we load it down. Following the trace. There's the output leg of the 12 volt. It goes to this diode here, feeds back, and goes to this trace down, follows through here. This goes down to that wire jumper, who sees the coil. And those are all 12. Let's see, I'm not sure what. Yeah, those are 12 volts. So they have a resistor divider here before it gets to 5 volts for that. Part's finally in. Okay. Packing this. I ordered, it came in a 4-pack. Comes with 2 of the 78L12s or 2 of the 79L12s. Total price was, I think, $5 for both of them together, all combined. And that's what they look like. Okay, so, if I recall correctly, the 12-volt regulator was not putting out any voltages, and that regulator was U3. And we did have input to that. And I'm studying where that input comes from. And it comes from over here. There's these resistors, and these 2 diodes and resistor. So I'm just going to make sure again there's no diodes shorted. I'll put this on just a 200 ohms resistance just to measure diodes. If they're shorted, that's what they'll show. Okay, so I'm going to go ahead and change out this U3 here. It has no output whatsoever. And we'll get it back into the garage door opener. And get it installed. I'm just going to take and just do a solder bridge across the leads and poke them through. If I can find my toothpick. If I can't, I'll just use the tweezers. I'll just use tweezers. I'll use that as a leverage. Just like that. So when I heat this up, it'll just fall down onto the table. And if you heard that, that's what it did. Now let's find the toothpick that I have to clear out the holes. We got our 12-volt regulator. I'm going to put him in. Make sure that I got the right one, and I did. I'll take a need to cut the leads off on that. And if I'm going to do that, I might as well make it square with the rest of them. Make it flush. Start at the top and solder the way down. Alright. And cut the leads off and get it installed. Let's measure our output and common. We now have 12 volts again. Sweet. Well, I'm confident to say that that was the problem. And now I'm going to go install it and show that the garage door works now. So I know that this says 12 volts, but that's unloaded. Once it's connected to the switch on the wall, then it becomes the 5 volts that you've seen earlier in this video on the other garage door opener. So don't let that 12 volts fool you. It's really 5 volts when it gets loaded down.